Hi everybody, today I am trying to continue with where we left off yesterday, looking at the principles of ecology and how ecosystems work. I believe this is where I left off, and I apologize, I was a little bit rushed finishing up on that video. I hope you bear with me. I mean, we all know that this is sort of a unique situation, so again, I apologize, but I'm going to try to make the most out of what we have. So I left off with this image, but I don't feel like I explained it very well. One of the things that I really wanted you to take into consideration here is that down here at the bottom, it's saying that 365 hens could be fed by a little over 3 million, so 3 1/3 million grasshoppers every year. But if you take those hens and then you feed the hens to the humans, then essentially only one human would be fed every year. So that causes a slight problem when we're looking at energy supply overall, which we're going to take a look at in some ways where this really applies. But if we change that, and a lot of people think this is gross, and this is more of a cultural issue, but if we shifted from having this intermediary where we have a loss in energy from the grasshoppers to the humans, if we had humans eat grasshoppers directly, eating the producers, or I'm sorry, eating the primary consumers, then we could end up feeding 15 times as many humans in that year with the same amount of grasshoppers down here at the bottom. So the amount of grasshoppers have not changed. The only thing that has changed is what we are eating. Now, I understand that seems kind of like an extreme example. That's one of the things that I'm not sure if you've heard about it, like Meatless Mondays, trying to find alternatives to how we are going to be eating. Some people have decided that on Mondays they will not consume any meat at all, trying to be more environmentally friendly, because meat is a huge environmental drain. Don't get me wrong, I love meat. Look at me, I love to eat, but really, if you're taking a look at how much energy and how much work goes into our food supply, if we ate lower on the food pyramid, or in this type of energy pyramid, these lower trophic levels, we could feed a lot more people because there'd be less loss between each step. So that's what I was trying to get to, and I don't think that I really covered that very well yesterday because I got kind of in a rush. Okay, so this is one of the items that I wanted to spend a little bit more time on. I think some of you remember this from the introductory biology class. So every organism has a range that they can survive in. Now those ranges will depend on the organism itself. That may be because of temperature, it may have to do with the amount of sunlight available, it may have to do with the amount of food available. It could be really a limitless number of environmental conditions. But every organism has a certain range that they can fit well into. And so you have this optimum range, which is where you get a lot of a very large number of species or of members of that population. But as you start getting further and further out and kind of get towards the edges of where that zone of tolerance is, organisms start to be stressed. And as stress increases, then you have all of these other things that increase as well, such as illness, decrease in the ability to reproduce, and so you're going to have fewer organisms that are able to survive in these zones of stress. And if you get too far out, if you were to, let's say, increase the daily temperature on Earth to 200 degrees Fahrenheit every day, that's getting to the extreme where we really can't survive anymore. You know, some bacteria might be able to, some individual organisms may be able to survive in that, but as far as humans go, we can't do that. So that would be out of our range of tolerance. Now, if you were to move us into the 120, 130 degree range, some people are going to be able to survive in that. Some people are going to be a little bit more stressed in that environment. But for the most part, we should be able to survive as a species. So that would be in that area of stress. Whereas most of us are very comfortable in that 60, 70, 80, even 90 degree weather. 90 degree might even be a little bit in that zone of physiological stress for some people. And then we have the opposite end where if we got too cold. So we have a range where we're very comfortable, and then once we get outside of that range, we become less comfortable. This is true for all organisms. And what we're really trying to look at here is how are we impacting their ability to survive if we are changing some of those parameters, those environmental variables, and affecting their levels of stress, and sometimes even move it into intolerance. So here's a prime example. This is a dam in Arizona, and we change the non-living environment frequently in order to fit our needs, whether that be transportation, whether it be for recreation. We put in dams just because we say, you know what, we want somewhere to be able to go in the summer. Sometimes we put it in for flooding control, and that's a reasonable, that is a good reason. However, when we kind of break that down, what we're doing is we're messing up a system that has been built over thousands or even millions of years. And so we're altering that environment to fit our own needs, but we're really not taking into consideration the needs of the other organisms. And some people say that's okay, and some people say that's not okay. And so what I'm asking you to do is evaluate, what are your thoughts? Do you think that's okay? Do you not think that's okay? Is there a way to kind of meet in the middle? Or is there a way to meet the needs of both sides? Maybe not a compromise, but maybe an alternate solution. So that's kind of where I'm trying to go with this. So when you have these huge dams that end up being made, then we're stopping the flow of water. The water starts to build up, and so dams tend to get lakes that are warmer than the rivers that used to travel through them. So it alters the temperature. You also kind of get this sink of sediment. So water that comes out on the other side of the dam is less able to support life because there may not be as many nutrients in it. The water flow overall, it sometimes becomes less oxidated. And so that can cause lots of problems. One of the issues, the fish that I have here is a razorback sucker. And it is incredibly endangered because the flow of water changed so drastically. So they warmed it up in the lake, so that made it so that the sucker could not live there. But then as the water comes out of the other side of the dam and the spillway, it becomes much cooler. It's too cold for the razorbacks to survive in downstream, and so they're essentially wiped out. They're not able to survive. Okay, so what I want you to be focusing on is that it doesn't matter what the ecosystem is. Organisms have to work together, and we depend on other organisms in order to survive, whether we depend on them as food or we depend on them for resources. One of the examples that I love to use, my wife hates bats. However, she loves guacamole, she loves avocados, and so I try to remind her whenever she sees a bat, it's like, I just wish they'd all get wiped out, is without bats, we probably wouldn't have guacamole or avocados because bats are the primary pollinators of those particular plants. So you have to think about some of these items and what the connections are. There are several other examples. Bees end up impacting our lives significantly, and so that's just something to keep in mind. When we talk about where an organism lives and the lifestyle that it leads, what it does in its community, we're talking about its niche or niche, depending on who you're talking to. I don't really have a preference on what you call it, but some people do. So niche or niche. And then we're competing for our ability to survive in that area. And we're not just competing with other members of our species, but we also compete with members of other species, and we're competing with the environment as well. So we're competing with non-living things just as much as we're competing with living things. So if the temperature changes, we're competing with ourselves, we're competing with nature overall in order to survive. But typically we think of the other living things, that's our competition. And so when a niche overlaps between species, then there's usually competition for the resources that are there. So if we're eating the same food as another species, we're trying to determine, are we going to do that? And we've done a very good job of that so far, is that instead of trying to compete for resources, we say, all right, so we're going to build the resources that we need. We're going to grow the food that we want to use in these locations. We're going to put up fences. We're going to use pesticides. We're going to do all these things to keep you out of our food so that we are competing using our brains rather than just the natural competition that would typically occur. Okay, so if two species completely overlap, usually one of them is not going to survive. That doesn't happen all the time. In many species, they are able to adapt, so there's not a 100% overlap. But sometimes it's enough that it will push a species out, at least to go extinct within a particular location. One of my favorite examples around here is we have pheasants, and people love hunting pheasant around here. However, pheasants have basically wiped out the native prairie chicken. So if you would have been in Iowa, a couple hundred years ago, there would have been tons of prairie chickens. Now prairie chickens, most of you probably have never even heard of a prairie chicken. And you'd probably be looking more at pheasants as being a natural something that it belongs in Iowa, but they're actually an introduced species. But their niches overlap so much that it was very, very hard for the prairie chicken to survive. So it really didn't. All right, so here's what I'm going to ask you to do today. We've been talking about niches. We've been talking about where things belong. We've been saying that organisms need to work together, or they depend on one another in order to survive. But humans kind of changed that. And so I have an article about Christmas trees that I'd like you to read. And as you read that, what I would like you to do is think about, why do we do that? That's referred to as a monoculture, mono being one, where we have one species of an organism in a location. So why do we do that? What are the benefits? What are the drawbacks? I'm also going to put a link to a website. I believe it's from Berkeley, and I'd like you to kind of read through that. And what my goal is, I'm going to put a discussion page up so you can put that on there. What I'd like you to think about is, why do we use a monoculture? What are the benefits of a monoculture? Because there are definite benefits. Everything that we talk about there are absolutely two sides. So what are the benefits of using a monoculture? But then also I want you to think about, what are the drawbacks? And then think about those drawbacks. Is there any way that we could realistically use agroecology, which is taking ecology in mind, or keeping ecology in mind as we are trying to execute agriculture. So how could we grow corn? Primarily we think of corn in Iowa as being a major crop. How could we grow corn in Iowa, but have it a little bit more environmentally sensitive? Is that possible, or is what we're doing the best option? So think about some of the items in the two articles that I'm asking you to read. Write a response on your discussion page and try to use some evidence. I'm looking for CER, claim, evidence, and reasoning. So what do you think? Is a monoculture a perfectly fine thing, or should we not have monocultures? Is your opinion somewhere in between? I'm not really concerned with what your opinion is. I mean, I want to know what your opinion is, but I really don't think there's a right or wrong answer. What I'm looking for is, what's your evidence for what your claim is? Okay, and then using that evidence, what types of reasoning support that? You can find evidence to support some ideas, but I want you to link that evidence and reasoning to say, okay, here's why I think what I think. Okay, so the goal is, we're looking at monocultures, how organisms relate to one another, how they impact each other's functioning in nature, and how does our influence, which the major thing that we influence ecosystems in a lot of different ways, but let's just focus on the one of agriculture, is that we have these monocultures, and how does that relate to these ecosystems? We're going to come back to agriculture later on, but we're going to look at it from a different point of view, and so I will just want to start with this idea. So if you have questions, I know I'm not there, I am just right next door, or you can also shoot me an email if you'd prefer, and we can talk about it at that point. So with that, I'll let you leave you to it, and just read both those articles. One is in a PDF, and one is a link to another webpage. So thank you. Have a good day.